All right, so today we're going to be working on the structure of the atom, because without atoms, we'd all be nothing. Because, well, yeah, we need atoms. We got about, we have a lot of atoms. There are more atoms in the in your body than there are atoms in the known universe. I'm sorry, than there are stars in the known universe. So, So the three parts of the atom. So we're going to start with a neon atom, and we're going to have, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And so I'm going to change color to, let's do red. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So, that is my nucleus. There are 10 protons and 10 neutrons. So I'm just going to put a key up here, equals protons, and then the black color is going to be neutrons, and then the blue on blue is going to be equals electrons. And atomic mass, I'm sorry, not atomic mass. The mass units for protons would be about 2,000. The mass units for neutrons would be about 2,000. And then the mass units for electrons would be 1. So our electrons, most of you are probably familiar with some version of this, which you might have seen in Jimmy Neutron Boy Genius. So there's 1. So these are considered orbitals, and there's a maximum of 4 orbitals in each electron shell. Now, since there's 10 protons, there's going to be 10 electrons. And let's see, and it's kind of hard to basically draw an atom. There have been multiple versions. One of the biggest versions of this was the Bohr model, and the Bohr model basically only works for hydrogen, where you have a proton in the center and an electron on the outside. But we use some variation of that to define or to basically describe what an atom looks like. So we have our protons. So I'm going to redraw that again. There's my red. So protons. And the charge on protons is positive. And let me get my book. Okay, the black ones, those are neutrons. And the neutrons are neutral. And then we also have our electrons. And our electrons have a negative charge. We're going to just use E as a not a subscript, as a abbreviation for electrons, and then we'll put the negative as a superscript. So, so protons. So if you have a positive and a negative, they're going to push away from one another. And if you have a negative and a negative, or a positive and a I'm sorry, I made that mistake. They're not going to push away from one another. They're going to want to be right next to one another. Because why? Well, because they're opposites. Opposites attract, at least in atoms. So we have atoms in charges. So we have a positive and a positive and negative and negative. Those are going to want to push away. And by the way, I'm just going to give everyone a fair warning. I make mistakes all the time. So if you catch me in one, please let me know respectfully, but yeah, let me know. So we have protons and neutrons and electrons, and they're all trying to come together. I'm going to move this down just a bit. I said a bit, not a lot. There we are. Okay, so the other thing about protons plus neutrons, they give us our atomic mass. And our atomic mass is the weight. However, weight is dependent on gravity, so needs gravity. I'm just going to put that in parentheses, gravity. And atomic mass is independent of gravity. So the atomic mass of the protons and neutrons would be the same on the moon as they are on Earth, be the same on Jupiter or the sun as they are on Earth. Now we have, I'm going to move this down. So protons and neutrons also, I'm sorry, our atomic number equals the number of protons and the atomic number also equals the number of electrons. So the atomic number equals the number of protons. The atomic number also equals the number of electrons. So for neon, neon's atomic number would be 10. The number of protons would be 10. The number of electrons would be 10. So, however, we would have now, if we're going to, I'm going to move this up just a little bit. If we were to add another element, the one right after neon, we're going to end up with sodium. So sodium is Na. I think it's for natrum, which is a Latin. So that'd be for sodium. And sodium has an atomic number of 11. It has a number of protons would be 11, and the number of electrons normally would be 11. Now, if we were to go with atomic mass, we would have to take the atomic mass equals the protons plus the neutrons. But if you look at your periodic table, it doesn't give you your neutrons. So we have to rework the formula so that you end up with, excuse me, so that you end up with being able to figure out the neutrons. Now we can do this algebraically, very basic, simple. So we subtract protons. Now remember, whatever happens on one side of the equal sign has to happen on the other side of the equal sign. So minus p and minus p. So, so that now we're left with atomic mass minus the protons equals the neutrons. And to make our lives just a little bit easier, we can flip that. So neutrons equals atomic mass minus the protons. So now let's do sodium again. So the neutrons equals our atomic mass for sodium is 23, rounded up. So 23. The periodic table I gave you has all of the atomic masses rounded so that your math can be a little bit easier. So neutrons equals 23 is its atomic mass for sodium. Number of protons equals the atomic number. So 23 minus 11, which equals 12. So the number, so electrons for sodium. So electrons for sodium equals 11. Protons for sodium equals 11. The neutrons, based on the formula that we worked, again is equal to 12. And we work that this way. So you take your atomic mass minus the number of protons, and that will equal 12. So our parts and our ways that we figure out different things for the atoms are, we're pretty much done. If anybody has any questions, my email address and phone number are in the course. If you're watching this online, you can contact me in the links below. Anyway, if there's any questions, please feel free to holler at me, and you have a great day. Bye now.